Now that we know how to find unit rates, how to turn different rates into unit rates, we're going to start to use those unit rates in order to help us solve some problems. So find this page in your note packet, and we're going to kind of work our way through a couple of these examples together to kind of give you an idea of how could I use unit rates to help me solve problems. So the first problem there is about a swimming pool. We've got two people who are swimming. It says Ethan swam 11 laps in 8 minutes. Austin swam 7 laps in 5 minutes. We want to figure out who ran or swam faster. Well, it's hard to tell because they both swam different amounts of laps in different amounts of times. So that's when it's really hard to compare them together. So as we've been talking about in class, when we want to compare them, let's break them down to the same size so we can compare them with each other. In this case, we're going to make them into unit rates. So same thing we've been doing before. For Ethan, 11 laps over 8 minutes. That's how we write it as a rate. To turn it into a unit rate, we always divide by our denominator, in this case 8, and we get 1.375 laps in 1 minute. That's his unit rate. That's how fast he's going each minute. Okay? Then for Austin, he swam 7 laps in 5 minutes. That's his rate. But we want to turn it into a unit rate to help us compare. So we're going to divide by that denominator. And he swam 1.4 laps in 1 minute. So the question asks, which boy swam faster? Well, Ethan swam 1.375 laps in 1 minute. Austin swam 1.4, which is really 1.400 laps in 1 minute. So when somebody is going faster, they're going a longer distance in the same amount of time. So in this case, Austin swam fastest because his rate is bigger. He's going more distance in the same minute. Okay? All right. Then we have the triad problem down here. Triad problem says Ashley is Austin's older sister. She trained in the same pool and she can swim 9 laps in 6 minutes. We want to know, is she faster than Austin up here? Well, again, the best way to compare is to turn it into a unit rate. So 9 laps in 6 minutes. I'm going to divide by my denominator to make it into a unit rate. And I get 1.5 laps over 1 minute. Well, in 1 minute, Ashley can swim 1.5. Austin can swim 1.4. So Ashley is swimming more laps in the same amount of time. So she is the fastest of those three. Okay? But we weren't able to compare those until we could turn them into unit rates. All right. Now we have something called a unit price. So a unit price is really just a fancy way of saying a unit rate, but it involves money. And the key is anytime we're doing a unit rate or a unit price, the money goes on top when we set up our rates. Okay? So we want to find the unit rate for the lunch special. So our lunch special is here. It's 3 tacos for $2.40. So $2.40 for 3 tacos. We want to find the unit price, meaning we want to find out how much it is for 1. Well, to go from a 3 to a 1, I'd have to divide by 3. So kind of like dividing by my denominator. So I have to do the same thing up top. I got to divide by 3. And I get 80 cents per taco. So the double number line, the picture form, is just one way of kind of showing how to tackle it. But we can do the same thing with our unit rates if that's easier for us. So now we're going to find the unit rate of the weekend special. 4 tacos for $3.40. Well, we want, instead of 4 tacos, we want to find 1 taco. We want the unit rate. Well, to get from a 4 to a 1, I'd have to divide by 4. So I got to treat the other part of the problem exactly the same. And I would get 0.85. So I get a unit price of 85 cents for 1 taco. Okay? Now, what if I asked which one was the better deal? Well, Here I have 80 cents a taco. Here I have 85 cents a taco. Remember, when I'm paying for something, I'd rather pay the smallest price I can. So the lunch special is the better deal. I'm only paying 80 cents instead of 85 cents. All right. So if you think you can handle this next one, I'm okay if you want to pause me and try it for yourself and then hit play. If you'd rather go through the problem with me, just keep following along and pause me whenever you need to. But this one says, explain how to decide which is the better value. 4 cards for $10 or 14 cards for $6. So best way to figure it out, turn them into the same size, turn them into unit rates. Find out the amount for one card, and that's much easier to compare than different prices and different amounts. So money goes on top. So $10 for 4 cards. I'm going to divide by 4, and I get $2.50 for one card. For my other one, it's $14 for 6 cards. I'm going to divide by 6 to find my unit rate. And I'm going to get $2.33 for one card. So now that they're both the same size, they're both the price for one card, I can compare them together. Which one's the better deal? Well, only paying $2.33 for the card instead of $2.50 is a much better deal. All right, last couple problems. We'll go through these rapid fire. I'm going to start over on the right first. So number 5 said 7 movie tickets for $56. We want to find the unit price, which is a fancy way of saying I want the unit rate. So money goes on top, 7 tickets on the bottom, divide by 7, and I get $8 for one ticket. All right, next one, 12 ounces of shampoo for $2.76. So $2.76 over 12 ounces. I'm going to divide by 12, and I get 23 cents for 1 ounce. Now remember, you can pause me anytime. You can rewind me anytime if you want to hear something again. Don't feel like you got to keep up with me as I'm writing. Then number 7, which is the better value? 2 books for $15 or 6 books for $45? Well, I got $15 for 2 books. Always divide by that denominator. And I get $7.50 for 1 book. Then I take my other one, $45 for 6 books. I divide by 6, and I get $7.50 for 1 book. All right, so we want to know which one is the better deal. Well, hopefully you're looking at it and go, well, they're exactly the same price, Mr. McKenzie. You're right. So they're both the same price. So they're both just as good of a deal. There's no difference in them. All right. Last one. Over on the left, it says car A travels 115 miles in 5 gallons. Car B travels 126 miles in 6 gallons. Which car gets better gas mileage? So who can go farther on a gallon of gas? So let's do A and B. Again, if you feel like you got this one, go to town. If you don't, follow along with me as I do the problem. So 115 miles over 5 gallons. I'm going to divide by 5, and I get 23 miles for 1 gallon. That's car A. Car B is 126 miles for 6 gallons. So we always divide by that denominator, divide by 6, because I want to know the price for one, or how many miles for 1 gallon. Here I get 21 miles to the gallon. So we want to know which one gets better gas mileage. Well, think about it this way. If I have a gallon of gas, I want to go as far as I possibly can with that gallon of gas. So in this case, 23 miles on 1 gallon is better than 21. So car A has the better gas mileage.